There are two types of circuits, the simple circuits and the complex circuit. To distinguish simple circuit from a complex circuit, a simple circuit is defined as a circuit which contains a supply, load, and connecting wires, as shown in this figure. So we have here one R and one supply voltage V. Now there are circuits that looks like complicated, but as long as you can solve the total resistance, meaning you can get a total resistance, then it is a simple circuit with one supply voltage. Simple circuit can be connected in series and it can be connected parallel, or sometimes it can be connected as combinational circuit, meaning series and parallel. Now let me define first series circuit. When current flows continuously, undividedly, and consecutively into the circuit is known as series. As shown in this diagram, there are three resistors connected, R1, R2, R3, and supply voltage V total. Now let's look at the properties of series circuit. So 1. The total applied voltage divides among the resistors connected in series. So in this diagram, the supply V total is equal to the voltage drop across R1 plus the voltage drop across R2 plus the voltage drop across R3. When it comes to current, you will notice that there is only a single current flowing in the entire circuit. That is also the same as the supply current I total, which is also the same current that will flow through R1, same current that will flow through R2, and same current that will flow through R3. So we can consider that I total is equal to I1 is equal to I2 is equal to I3, or simply equal to a value which is I. To get the total resistance of the circuit, we can use equation number 1. So using equation 1, you substitute Ohm's law, that is IR, that will give us V total as I total R total, V sub 1 as I1 R1, V sub 2 as I2 R2, V sub 3 as I3 R3. But you will notice that same current throughout, or represented simply as current I. So you can factor out I. Okay, so by simplifying, that will give us equation number 3, that the total resistance is equal to R total is equal to R1 plus R2 plus R3. We can also connect circuit in parallel. So by definition, sabi natin dyan, when current divides into the different branches of the circuit, as shown in the figure, there are three resistors connected in parallel, R1, R2, and R3, with supply voltage V total. Now let's look at the properties of this parallel circuit. The total impressed current IT divides among the resistors connected in series. The higher the resistance, the lower the current that will flow through. So I1 plus I2 plus I3 will be I total. Okay, that's the equation number 1. So next is equation number 2. How do we get the properties of voltage? So same voltage across or throughout Y. They are only connected to the same point or same terminal. So if you measure voltage across R1, that is also the same as voltage across R2, which is also the same as voltage across R3. Okay, to solve for the total resistance, get equation number 1 again. Then you substitute the value of current I as voltage total over R total. For I1 is V sub 1 over R1. For I2 is V sub 2 over R2. And for I3 is equal to V sub 3 over R3. But of course, we know that the supply voltage are equal or equal to voltage V. Then by simplifying this equation, that will give us 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now, in this equation, this is simply the reciprocal sum is equal to the reciprocal sum of the individual resistance connected in series. Now let's proceed now to simplification of simple circuit. There are simple circuits that looks like complicated circuit, but can be reduced in such a way that it contains a power supply or supply voltage, a resistor or load resistor are total, and connecting wires. So simplification of simple circuit starts from the outermost part. The outermost part is the one farther away from the supply voltage to the innermost part of the circuit until it is now represented by a single resistor called R total. Now let's try to apply it in problem. So find the total resistance of the circuit at terminal AB. So our intention here is to get R total, meaning RAB. So we simplify the circuit. You will notice that 5 ohms and 4 ohms are connected in series. Okay, that will give us 9 ohms. 2 and 6 ohms are connected in series. That will give us 8 ohms. Okay? So yung 8, 9, and 12 ohms in the circuit are connected in parallel. So I use parallel property. And that will give us the reciprocal sum. 1 over R total is equal to 1/8 plus 1 over 12 plus 1 over 9. So take the sum, then take the reciprocal using your calculator, and it will give us an answer. R total is equal to 3.13 ohms.